The idea of reality capture, if I can get this to work. There we go. So reality capture is essentially taking the real world and digitizing it. So for the most part, when you end up seeing reality capture or people taking reality capture, it tends to be more of a laser scan. So they might have this big machine on a tripod like you'd see over there, and the result of that ends up being very pixelated. So you'll end up seeing all these little dots in space. So the main idea here is that you're taking the real world and you're putting it into a digital format. What you use that digital format for really depends on what your background is. So I was asking for, are you looking at this from the standpoint of civil or site, from architecture, from museum work? The idea is, okay, well, you're giving yourself a toolkit, and how you utilize that tool really depends on what your background is. So for example, what I'm looking at right now is just a point cloud of sort of a kitchen space, but that kitchen space is very ornate glazing. On the right, you'll see an image of more of a workshop. A lot of the times what I see when I'm working with people is taking the laser scan or the different kinds of reality capture and then creating a physical 3D model from it. And that's what you see in the middle photo there. So if I zoom in a little bit, what you'll see is a lot of solid geometry that has been built by tracing the reality capture. Now, depending on your use, it may or may not be necessary to do that. But this allows you to take that information and then work forward from that point, making sure that in the case of architecture, your existing conditions are accurate. You're not working off of a set of drawings that were what people built from. You're working from actually what they built. Now, the basic kinds of reality capture tend to break into laser scans, photo-based, or sensor-based. There's one that's sort of halfway between photo and sensor. Now, on the laser stand, again, you're typically going to see something on a tripod. It's going to have a little machine on the top. What that machine actually has is a laser and a mirror, in very simple terms. What happens is, the animation's not rolling. So what happens is that laser will actually hit that mirror, and the mirror is going to spin around in 365 degrees. So it's actually going to be capturing thousands up to millions of points per second per minute, depending on the kind of hardware you have. Now, this hardware is not just for terrestrial units, meaning it's not just going to be something that you put on a tripod. You can actually run this on planes, and there's also versions that are designed to work off of vehicles. So again, it depends on what your application of, but the end result is still going to be a lot of points that have their values to tell you where they exist in space. And I'm going to touch a little bit more in that in a couple of minutes. Now, another one, this is the one that's sort of halfway between the photo and the sensor, is something called structured light. If anybody here had a Microsoft Kinect with the Xbox 360, you actually had a structured light scanner in your house. How this actually works is it shoots out infrared light onto a surface, and that infrared light is constantly moving. So you should be able to see this little GIF here of a whole bunch of little white dots moving around on a black surface. What that actually does is it shoots out infrared light, and by reading what happens from more than one direction, you notice the Kinect has more than one camera on it, it's able to infer what's happening off of surfaces. So that way you can actually scan, and in the case of the Kinect, put together a skeletal model of the people using it. But you can also hook that Kinect up to a computer and use it as a poor man's laser scanner. So I've actually done a bunch of testing where I used that to scan rooms. It's definitely not going to put a $100,000 laser scanner company out of business, but it's something that you can do that's fun. And the image on the right there is a little thing that you can adapt and put on an iPad. Same exact idea. And then you can actually scan a space with an iPad or an object. And this is something that is purpose-built for scanning rooms, more for residential, but again, it's built off of the exact same sensor technology. So it's not really a laser scanner, it's more structured light. Now, photogrammetry, this is what the question that was in the Q&A, so maybe people understood it, maybe they didn't. Photogrammetry is the act of building objects, models, point clouds, using nothing more than photographs. Now, the photographs don't have to be special. You can use a DSLR, you can use a cell phone camera, you can use a GoPro. It doesn't have to be any one specific kind of camera. Now, from here, what we tend to be doing a lot of lately is using a camera that's on either a UAV, a drone, quadcopter, same idea, just different terminology. And you can hook it onto one of those, or you can hook it on something that's more of a fixed wing. The end result is you're capturing a large amount of information by having a lot of photographs that overlap each other. And that's one of the key things, is to make sure there's a large amount of overlap. The reason for that is if you've ever had to draw a perspective by hand, what you end up doing is you figure out where you're looking at, you work out what your vanishing points are, you work out where the lines are for everything so it understands where it sits. What software tends to do is it looks at image after image after image and compares the pixels. And in many ways, what it's actually doing is deconstructing the image. It figures out by angles and lines where the vanishing point is and works on multiple photos and then stitches them all together. Now, if you actually wanted to have scale, you can very easily attach a scale to it, and then you can actually utilize that to build off of. And I have some examples later on that I'm actually going to show. Now, one here is sensor-based. Now, both of these ones here, the examples that I have, are based off of an iPad. So what you end up doing is looking at the one on the left, which is called Room Scan. That actually allows you to take an iPhone or an iPad, and walk around the room and actually put it up on the wall, from wall to wall to wall. It's a little hard to see here, but there's actually sort of a gray pathway in this image. So let's see. That's that. You can kind of see this little path here. That's the image by using the accelerometer and the location information from the device, so it figures out how you're moving around. And by actually putting it on each wall and hitting a button, it's able to figure out, or attempt to figure out, what you're actually doing and what the space you're in looks like. Now, the other one there is actually called Magic Plan, and that one works on Android as well as iOS. And essentially what you're doing is you're looking at objects in the camera, and you're aligning graphics from the software with what you see in the photo. And by that, you're able to set up a scale, look at the room, and actually have it build a plan. And you can utilize that plan to actually create floor plans and export that out as like a PDF or a DXF. Interestingly enough, they have a couple of specialized versions of this. One of them are specific to police usage for CSI. So the idea of using reality capture is not just within the design or the historic community. It's something that works with just about everybody. And just another method of actually capturing the real world around us. Not everything has to be in 3D. In some cases, all you really need is just a 2D plan to work off of. Now, focusing more on the 3D side of things. So if I'm looking at what essentially is a point cloud, this is sort of a typical example of what people would expect when they see a point cloud. Everything here has color to it, and it looks sort of real. Now, most point clouds are very much like a screen door, meaning that if you're looking at it from far away, that screen door looks solid. As you get closer and closer to it, you start to see all the space between the actual screen elements. So, same idea. Now, by looking at this image, I can see all the objects, and I can see these little things here that look like orbs. Those are actual locations where the laser scanner was to actually capture that relevant information. Now, that can be important because it's not just capturing the right color of the object, capturing a lot of other information. So you have the other XYZ, so it knows where the point should physically exist. In this case, it's actually manifesting that. So you can tell, depending on the software that you're using and how you captured that laser scan, what you want it to look like. So graphically now, what it's showing me is just by color, the elevation of certain parts of this image. Now, this is relatively small scale. I'm just looking at buildings. It's not like it's 300 feet tall. But if you have a very large area, maybe you're scanning a quarry, maybe you're scanning an existing building, or maybe you're scanning a very detailed surface of a historic element, and I want to get an idea of what the variance is, I can graphically have it do that for me. Now, in addition to that, I can have it colorize it based on the strength of the scan of the objects. I can have it look on the actual normals or the direction that the points feel they're facing. I can have it colorize it based on the actual locations. So each scanned location will get its own color. So there's a lot of little bits of information inside of every one of those little scans. So it's not just a location in space, it actually has a lot of other data built into it. Sorry. Now, the typical benefits that you're going to see from laser scanning tend to be existing conditions. So 90% of the time when someone's doing a scan, they're just trying to capture the actual conditions at that point in time. Whether it's because there are no existing documents of a building, whether it's because they know the documents are out of date, or they're actually going through and rebuilding it. Other ones is confirming the as-built. I mean, if you've designed a building to be a specific way, you want to find out how close or how far the actual end result is from that. And that way you can actually utilize that moving forward, whether it's from a management or documentation or design, analysis, coordination, clash detection. And this is not intended to be an exhaustive list of uses, but these are the main ones. Now, the image on the right there is actually an image from New York City. And this one was actually used for analysis. So not flying a drone, they actually flew a normal fixed-wing airplane over the city. And this was, I want to say this was probably around 6-7 years ago. Now, the goal of this was to get a scan of the building rooftops and get an idea of what percentage of the rooftops could actually be utilized for solar power. From that, then they can actually determine, well, how much energy are we actually generating from solar in New York? How much could we be generating from solar in New York? So little things like that. What they actually found that was 66% of the buildings actually had roof space that was suitable for it. And that would actually work out to about 5,847 megawatts from the buildings. So right now they're only getting about 6.5 from 400 installations. So it's just an idea of looking at what you have and what it could turn into just from a quick flyover and running an analysis on that. So nothing that exhaustive. Any questions from anybody yet? No? All right. Now, in terms of using the reality capture results in AEC, when we did the little survey in the beginning, the majority of people actually did check the box for architecture. A lot of people tend to use it for background imagery, clash detection, and reviewing queries, and actually building the model, like that initial icon that I had there. A lot of the things that people are starting to take advantage of, though, are the background imagery. So if you have a building that you're putting in or a design that you're putting in, a lot of the time when people were starting to move to 3D, problems that you would run into was people would try to build everything, including things that were not in contract or not even needed. So now that you've got something that you can build off of, same exact problem. But in an instance like this, on the image on the upper right-hand corner, all that is just a couple of walls and a door and a window that's actually modeled. The rest of that is using the reality capture or the laser scan as background information. You're almost using it as, just a false front. So I'm not going to need to model all of that when I can just show that for reference. So I'm actually utilizing the existing conditions just as part of my drawing, as opposed to using it to actually build a brand new model. So you're taking advantage of what you already have. Now, the clash detection and comparisons, or you're designing, like let's say you're working on a more of an infrastructure project or something like a bridge. The clash detection is right there. Most of the software that does clash detection works natively with the point cloud data now. You don't have to physically turn it into a 3D model just to be able to do that. The comparison side of it also, though, is taking a scan or getting more reality capture data over time. You can actually compare and contrast how things have changed. So if you're looking at it from a standpoint of historic preservation, maybe you have a building that is very old and you know it's degrading. Using that reality capture data, I can actually scan it, several times a year, at each portion of, like the beginning of each season. And I can see how much is it moving? Is this sagging? Is this actually starting to deteriorate? So you actually have a snapshot in time that has a lot of data involved in it. It's not just like a photo and you have to sort of interpret, well, I think that dropped down 1/4 of an inch or 1/2 of an inch. You actually have something that scans the entirety of the element in 3D, and then I can actually quantify any changes that are occurring by comparing them and contrasting them. So this is just an image of doing a clash detection using a physical model, that would be the pipe, and the reality capture data, which would be the beams. Now, one of the things is review in queries. with a lot of the software that most people tend to use, that software is not available to everybody involved. And a lot of these things, they can be very expensive. There are free tools that are available to people to actually view and review reality capture information. So the image that I'm showing here is from a program called Recap. And one of the nice things about that is it allows you to actually look at and view in a much more comfortable environment, meaning a lot of these files are really, really big. This can handle that. But it allows me to look at them and actually get dimensions. It also allows me to put notes in there. So if I'm trying to track information or say, okay, well, this is where we have to focus, or what is going on here, it actually allows me to do that. So I can actually find out, in this case, the dimension across that window opening. I can put a note on that window. Now, not part of the free one, but if somebody actually does have access to the paid one or to some of the other paid services associated with this, they can actually upload these notes and dimensions to a website, and then anybody that they've allowed access to can then go on to that for free. And the same thing, get dimensions and upload comments or information. So if you need to share this result with other people, it's something that you can actually put out there so anybody can take advantage of. And in most cases, the typical usage of this is to build models. So what we're looking at right now is actually from a program called Revit. This actually has all the point cloud data at the same time as the 3D model. And you can actually see little things here. Those are the actual datums or connection points that you would use so that when you do take the scan, the software can help stitch all the multiple scans together. But everything else here is all 3D from the software program, and it was done by tracing and lining things up with the reality capture. Now, I noticed when we did the query in the very beginning, a couple of people actually said they have used laser scanning. Now, I'm not sure if that means you've received laser scans before, or if you've actually gone out in the field and conducted it. I'm just going to go over a couple of quick best practices for if you are actually doing laser scanning. One of the biggest things with scanning is making sure that you have a lot of overlap, meaning that if I take a scan with one and then take another scan in another room, I want to make sure that I'm covering the most bases, but that I am also making sure that there's enough overlap for each scan to understand how they relate or react to each other. In the case of what we're looking at the field of view that each scanner has that is specific to each other. And you can see how on these two, they're only able to get the corners of the room that they're physically in, whereas in this case, each one can grab those corners. That allows these to actually have a common field of view and have more points that they can actually line up with. So when I was back here, and I pointed out these items, so that actually is the same kind of an idea. A lot of the times when you go out into the field and you're doing scanning, you're going to go out with either pieces of paper that have what looks like a datum on it. You might have something that has a magnetized bottom. It almost looks like a board game pawn. And you can stick that on metallic surfaces. So that way, as you move around, you can see that in the scans, and the software can help align the results. Now, in cases like this, you can very easily turn one that's not good into one that is good by having an additional overlap scan to help tie everything together. Now, I mentioned before about having the corners. And the geometric constraints, meaning that I have a physical thing that the software can interpret and understand what it is. So if you have one really long white surface on a wall, it's bland. There's not a lot of data there that the software can work with to help it understand how scan A and scan B align. But the more unique identifying elements, in this case a physical corner of a room, the better and the easier it's going to be to have that software work with each other. So, some cases, one of the best things to know is what is the intended use of that laser scan data. Now, the reason why I say that's important is when you get a laser scan, there's a lot of little things that you can tweak, meaning how accurate does it need to be? So is it 1 millimeter? Is it 5 millimeter? Is it ½ inch? You know, what's the accuracy that you're going for? Is it sort of a very detailed element, or is it more gross overall space? What is the data that you need to be inside to have in there? So when we were looking at that early image, I showed how that same scan had elevation data. It had individual scan data. It had the intensity data. So all that information is inside of that. A lot of the times what we see with our own clients is somebody will ask for a laser scan and then they'll receive it and it's in the wrong format or possibly the wrong scale. So there's a lot of little things to have in the very beginning and say, okay, well, what do we want to scan for? Okay, we want to build a model from it. So the more information that you have up front in terms of what you think you want to use it for, the better your results will actually be when the people either taking the scan is yourself or another person. You're going to be able to communicate a little bit better and make sure the results you get work for your end result. And that ties into the deliverable format. So are you getting one file that has everything already merged, or are you going to be getting a whole bunch of separate pieces that you now have to put together? And in some cases, the physical space can be very important. If you have a lot of transparent, reflective, or possibly problematic areas, like if there's a lot of chrome, you might see a lot of shiny metal in something like a mechanical space. Those can be a tough sell. And laser scanning is definitely more resilient and more accurate than photogrammetry right now. So you won't have as much problem in terms of lighting, like if it's light or dark or shadows. But you do want to keep that in mind in terms of what it is that you're shooting and how many scans will you need to make sure it's accurate if you have areas that are going to possibly have a good amount of noise. And noise would be all the fuzz in the air. If you're reflecting, it wouldn't actually have a solid thing to hit. And I mentioned a project survey control. What that means is that there is actually a point within the project. Let's actually back up a little bit again. So let's say within this building, I have a column right there. I want to make sure that all of my scans understand where that column is relative to everywhere else. So for certain things, if you actually have a GPS connection, you can say that this scan was taken at these physical coordinates. But you want to make sure that there actually is some sort of a survey point to tie all of your scan data together, because that makes it a lot easier after the fact to, number one, stitch them together and have it really understand what the end result is. There's a lot of little things that you can do like that. Now, moving on. Photogrammetry is something that is not relatively new, but it's getting a lot more play and it's getting a lot more notice these days. So probably about 5 years ago, there was a story where a university using Microsoft software, I believe it was Photosynth, they actually built a model of the Colosseum using nothing more than photos off of Flickr. So again, not really new, but the difference now is that you don't need to be a university with a supercomputer or direct connection to Microsoft. A lot of these things you can do completely for free, just taking photos with your phone and then uploading when you have connection to Wi-Fi. Now, in terms of doing this, one of the best things to remember is to try to get all of your photos with a lot of overlap. You don't want to just take one photo from each corner and then say you're finished. So in this case, you can see how many photos would just be going around one element. So in this case, we have maybe 79, 90 photos going around an object. And then you actually want to move up maybe 5 to 10 degrees and get it from another angle. So the more photos that you can get, the more accurate things will be. And one of the other things that you'll find with this kind of workflow is that if you can set all the photos up to be in order, so that meaning I'm not going, right, left, and all over the place. You're kind of going 1, 2, 3, 4 down the line. While not absolutely necessary, it does enable the software to be more successful in stitching all the photos together. So it makes it more likely that the result that you get will actually be better. And if you have a small portion of an object that you want to get a lot of detail on, you want to make sure that you get as much of the object in the frame and then work your way in towards it so it has reference points as you do that. So in the case of something like a room, I wouldn't want to stand in the middle and then just shoot all the way around. And I'm just getting one angle from everything. What you want to do is sort of keep your back to the wall and move yourself around the room. Now, there can be a few issues with this. What you don't want to end up doing is going into a room that is 4 white walls and maybe 1 door. So the software is going to have trouble with that. What we've actually done when we've tested things like this is go in there with a couple of sticky pads that are different colors and just randomly put different colored sticky notes on the walls. Just having something as little, simple as that helps the software look at it and say, well, this photo here is different from this photo. And it helps it align it and stitch them all together. It doesn't take a lot, but as long as there's enough of a difference that the software can tell, it'll actually work out. Okay. So for photogrammetry, you want to try to get as much of the object in the frame. So you don't want to start zoomed tight on the element because it's not going to know where that is. If you do have to get a detailed photo of a specific portion of something, that's not a problem. You just have to sort of get an establishing shot of where it exists in the whole thing, and then you can work your way forward, and it'll understand photo to photo the transition to where that object or that detail actually exists. So in terms of how often, figure every 5 degrees you take another photo. A big thing with photogrammetry, though, is the lighting, because the software tends to look at each pixel in each photo. Taking photos one day in the morning and another day in the afternoon, it can throw things off. You're going to have very distinct shadow lines in different locations. It might think it's in a completely different location, even though it's the same spot. It just has different lighting. So the more indirect or even or consistent lighting you can get, the better things will actually be. And where possible, use a tripod, just to keep it in one spot. Now, in terms of things that you do not want, you don't want to be in direct sunlight or very dark areas. So some photos that we take interior, if you have a light that's directly in the line of sight, you're going to have a big bright spot. Excuse me. That can actually throw off your results very much. So you don't, when possible, you want to remove that. Again, if you can have more even light, things will be more successful. Same thing for blurry photos or moving objects. If you have people kind of in some of your photos, more than likely you might have remnants of that. So like a half ghost-looking head in one of the models, because it was there for 1 or 2 images and then it's suddenly not there. So again, it's going to be confusing the software. Changing the camera settings, you might be tempted to do that specifically because you realize some things weren't coming out correct. You can change it, but again, it can introduce problems. So when possible, you don't want to do that. So same thing, shiny objects I mentioned before. The reflectivity can definitely mess things up. I've had medium success with some things, but it's a catch as you can. And you don't want to take all your photos from one location. So that image of sort of the floor plan, that's what I mean. You want to move your way around so that way you get different vantage points. You don't want to just stand still in one spot and hope for the best. Any questions with anything I've gone over so far? Okay. Perfect. So what I'm actually going to do is I'm going to switch over to sharing my desktop, and I'll actually show you a couple of things with the actual software that you can utilize for this. Thank you very much. Share my screen. Yep. So what we're actually looking at right now, let me move this over here. And just to make sure everybody sees what looks like a wood shop. John, can you see what looks like a wood shop? Perfect, okay. So what I'm looking at right now is a program called Autodesk Recap. And don't worry, any of the software that I mentioned, there actually is going to be a set of information afterwards that has links to where all this is. So this is one of the tools that Autodesk puts out. They're a company that makes AutoCAD, Recap, Navisworks, Revit, a lot of that. And this one actually is available for free. Now, what I'm looking at here is actually a laser scan of a portion of a wood shop. So again, as solid as any of these surfaces look, as I get closer, you'll start to see just how pixelated or how it really is, just a series of points in space. Now, within this area, I have those little orbs. You're going to notice that where these are, there's sort of like a dead zone or a blank surface, a circle underneath each of these. Those circles denote where the actual scanner was. So again, when you actually use a laser scanner, typically what's going to happen is it's going to scan in 360 degrees in plan, and it's going to look upwards as well. But it can't really scan, at least at the moment, underneath itself. Now, if I click on one of these orbs, what it actually does is it takes me into a panoramic view. So this is more of a photograph. Now, the interesting thing is, even though this is a photograph, it still allows me to do things like get distances from objects. And while this is showing me things in metric or imperial, depending on what I'm choosing, the data is the data. I can very easily go in and manage or modify what the scale, what the distance is in a different format. So I can come in here, I can put in notes, I can put in distances. If I have multiple views here, I can bounce back and forward them. So if I want to hop into a different scan, I can. And if I want to go back to the point cloud, I can do that as well. Now, one of the things with point clouds that tends to be problematic for a lot of people is that the files themselves can be very, very large. So if you're familiar with using AutoCAD, you might find that your files are anywhere from, like, say, 2 megabytes up to maybe 20. If you use Revit, you might find that your files are anywhere from 40 to 400 megabytes. If you get a laser scan, your files might be 400 megabytes to 4 gigs, and we've seen much larger. So without, it doesn't really need to be said, but these can be very big and can also make things very slow. The nice thing is the Recap software is designed for that, so I can easily move things around. But more than that, it allows me to break the file up, so that way when I bring it into another program, whether it's AutoCAD, Revit, or anything else, I can actually manage this a little bit better. So in here I can actually see my 2 scanned locations. I can turn these on or off. But more important are my scanned regions that I can actually create. So if everyone here is familiar with AutoCAD, think of a scanned region as a layer. So if I hover over here, that's highlighting all the elements that have been deemed equipment. If I hover over floor, highlights all the elements that are considered as part of the floor. What this allows me to do is very easily turn on or off different pieces, so that way I can focus on the information that is necessary for what I'm doing. Now, there is no button that automatically creates these. So this is a manual thing. But it's manual in the sense of I just have to click on that surface, and it will automatically select any points, plus or minus, from the plane that I just created. So if I want to grab all of the floor, I can do that and say grab everything within, a 1/4 of an inch of that floor. So in this case, there's a little bit of variance on that floor, so maybe a little bit more. So that gets me the floor. I assign that to a specific region or layer, and now I can manage that. And if I turn that off, now when I get to the pieces of equipment that are much harder to select typically, all I need to do is come over here and do a simple window. And then I can actually select that. I can delete that. I can clip that in or outside, so that way it's easier for me to actually see what it is that I'm working with, and make sure that when I do decide to take this to maybe the next level or the next thing, I'm only bringing in the data that I actually need. I'm not bringing in all this extraneous information. So this file has all those things. It can also have specific view states. So again, if I need to share this information with somebody else, I can save specific views. And one of the things that we actually looked at in the PowerPoint is the ability that we can actually look at information in different ways. So what this is doing is just graphically telling me that anything that's in purple, that's 13 foot 1 feet above the ground. Anything that's in that green is sort of in the 4 to 6 foot range. So it doesn't have to do anything else. All I'm doing is telling it how I would like to actually interact with and view this model. And in that case, I can always do the same thing, change it to things like normals. And one of the questions I tend to get asked a lot is, how could this view ever be useful? And it's actually a very honest question, and it does make sense. The thing is, if you notice here, when I'm looking at it in normals, I can actually see that bend in the fabric there of that sign. If I tell us to look back at RGB, you really can't see that. Now, the fabric might not be the perfect example, But one of the projects that I did for a client was actually taking the laser scans that they received and building a Revit model from that. And we needed to be very accurate with a lot of different things. The problem was it was relatively dark in corners. So corners of a ceiling, corners of a closet, corners of rooms. And when you're looking at it like this, sometimes it's hard to make out the details. So you're just looking at the red, green, blue values that we normally see. And when it's dark, I can't really tell what's happening. But if I change to something like this, I can very clearly make out the end of that beam. I can very clearly make out the fact that this is not flat. So even though it might look weird, I'm able to get more information from this than I might be able to get from something like a regular or a standard colorized image. So just because it looks weird doesn't mean it's not useful. And in this case, a little hard to see because there's only 2 scans, but you can tell the differences based on the different areas. More so if I turn these on or off. Now from there, I can modify my lighting if I want to view this or use this as a presentation. I can change the point display to be a little bit finer or to be a little heavier if I need to read it that way. And one of the big things here is setting up your orientation. Now, if I'm going to be bringing this into, say, an AutoCAD file or a Revit file, I might want this to drop in at a specific location. What I can actually do is click a spot and actually say, okay, well, this is where I want this to actually exist. And maybe when I bring it in, I realize that the whole thing is sort of angled to the wrong direction. Okay, well, let me click specific sides. Make sure that it understands where up is, where down is. And realign everything. And then after that, I can orient it and organize it to be how I need it to be. So little program, relatively simple. There's not a whole lot going on here in terms of things that I can modify or break. If you need to only see specific areas, I can always create like a section of it. So I can just focus on specific areas without needing to go crazy and hide a whole lot of things. But this is to make my life easier, whether it's really just getting a dimension or preparing this for me to build something from it. And if I am going to build something from this, I can either publish this to Recap 360. Recap 360 is an online portal. I'm going to be going over that in a couple of minutes. Or I can just tell it that I want to export this out and send that to something that is more of another tool like AutoCAD, Navisworks, Revit, something like that. So pause that. Okay, no questions yet. Cool. So the thing we were looking at is Recap on desktop. Now, one of the things I mentioned there was Recap online. And, yep. Where is my share button? Stop sharing, share my screen. Give me 1 second. Go. Now, Recap 360 allows me to view uploaded point clouds from Recap on the desktop. Now, in addition to that, it's also one of the tools that allows me to create photogrammetry. So when I log on here, I can see some of the recent projects I did. I can look at the project gallery of different things. This right here is what we were just looking at. So I uploaded the point cloud from my desktop and made it so that I can actually view it online and actually be able to put notes on there and go back and forth. Now, for those who were looking at the initial slide of the presentation, I had 2 images on there. One was that little kitchen that I showed. The other one was a lion statue. Now, when I was up in Vancouver, I was speaking at the Revit Technology Conference, and there was a really cool Chinese gardens there, and out front was one of these lion statues. Now, honestly, I wasn't paying too much attention because I really didn't think it would be that good, Yeah. But this was done with my cell phone. So figure about minute and a half worth of me taking photos, basically holding down the photo button and walking around it. That's all the real effort that I put into this. And if I was putting a little bit more time into it and also a little taller, the top of this would have been smoother. Now, even when I zoom in here, you might say, well, you know what, it doesn't look that detailed. Part of the thing is because I'm viewing this online through a web browser, you should be able to see this little icon or this little note on the top. It's going to simplify this. So what it's saying is that this is a proxy mesh, meaning that it's not the actual result that you've got. It's a simplified one, so that way it can be viewed online. So this is about 200,000 triangles. The final one is 608,000 triangles. And in this case, if I wanted to see some of the detail, you can actually see how detailed that mesh is. I can come through, modify things, cut them off, orbit. And if what I'd like to actually do, there we go, is actually see one of the photos, I can click on a photo I took and actually see the angle that that photo came from. So you can actually see how it kind of lines up and stitches in with this photo or with the model. So if I have something here that doesn't look right or I ran into some problems, I can sort of look at the photos and see, okay, well, where's that issue lie? Where did I go wrong? And if need be, I can actually help the software stitch things together by giving it a little bit more information or confirming that 2 points are the same in multiple photos. So this actually allows me to do that. Now, how this actually works is you creating a photo project, giving it a name, and you can do preview or ultra, and then you choose the file format that you want. Now, the main thing here between preview and ultra is that ultra is not free, preview is. If you do ultra, it'll give you more formats that you can work with. So RCM is a mesh format, RCS is actually point cloud format. And same result for right now, depending on what you need it to be though. Once you've gone through that, you upload whatever photos that you want to assign here. And if you care about scale, then I would go through and actually help it understand scale by looking at more than one photo at a time and saying that the distance within the photos is a specific distance. So what I mean by that, let me hop back here. So let's say I look at something a little bit different. So this is a little rough. It was a study that was done on a roof of a mechanical system. Now, in this case, I know exactly how wide that piece of equipment is. So within the different photos, I can click on that corner, and I can click on this corner. Yep. And then I can tell it that the distance between this corner and that corner is a specific one. And then from there, as the software stitches everything together and figures out where everything should line up and how it should be put together, it will actually scale the rest of the model to that. And again, this one might look a little bit rough, but again, it can only show me 200,000 triangles in the website. The final one of these is about 8.5 million triangles. And this could be used for a lot of different things. So some of these might look like, you know, a little bit cheesy. One of our groups in California was doing a class more for media and entertainment. So if you had something like an action figure or a toy or something, and you needed to very quickly scan that and bring it into something, you can do that. And if that's not really the need, you can also do this with the drones. So one of the other examples here is us flying over a client site and actually taking imagery from that. So this is Recap 360. This is completely cloud-based. And this allows you to do different photo models. Sort of in the same line as this. Sorry, I didn't get this one ready first. There's sort of a hobbyist version of Recap 360, and that's called 123D Catch. So Autodesk has a series of free software for hobbyists or makers. 123D Catch is one of them, and works on the PC, works on the Android as well as iOS, and essentially it's sort of like a light version of Recap 360. You are able to take all your photos, upload them, the software then stitch them together, and then you can utilize that for whatever it is that you need it. Whether it's something like statues like I showed with the lion, little toys or heads, buildings. So a lot of little things that you can actually use for this. And this one here is completely free. Now, everything I've been talking about so far has resulted in a point, meaning all these little points in space. Now, sometimes what you need is a physical piece of geometry. And normally you're going to run across that in one of two ways. If I bring that geometry, or if I create that geometry in something like this. So what I'm doing now is I'm in a program, and that program is called Revit. So this here is just a file that I've brought a point cloud into. And inside that file, find where it is, there we go. I can actually look at the point cloud that comes in there. I can essentially trace it and build my model from there. So I can draw walls that line up with the actual point cloud. I can actually place the windows where they need to be, place the doors, put in the equipment, and work off of that, and then have that solid geometry that I can actually build from or analyze or create my documentation from. And while I'm showing this in Revit, I can easily do the exact same thing in AutoCAD and many other applications. Excuse me. So it just depends on what it is I need to see. And this right now is showing me the top. So basically looking at the ceiling from the other side. And one of the things that we were looking at before was I was saying how I can look at this in different forms. All the data that was inherent to that point cloud is still available in it, meaning that I can actually choose what color mode do I want to see things in. So again, RGB, that's red, green, blue. That's all the different colors that you would typically see in a regular photo. But if I'm having trouble understanding that and I want to see it differently, I can say normals. If I want to be able to look at this and very quickly get an idea of elevation, I can choose that and say what colors I want to actually see as it creates that range. So I still have that ability to look at the information in a form that helps me create and work with it. Minimize this for a second. Now, this is sort of the typical way that most people are actually going to work with. They're going to take that in, they're going to build from it and work on it. Now, Autodesk has another tool here called Memento. Now, it's Project Memento because it's still technically in beta. Now, what this allows me to do is work off of different elements. So when I was looking at Recap 360, that was the web-based one, that allowed me to take photos and build 3D geometry from it. Now, once you have that 3D geometry, what do you do with it? You know, one of the things that it mentioned was that those objects that it creates can have millions of triangles, meaning that it can be very, very heavy. So trying to bring one of those into something like, say, 3D Max or Revit or AutoCAD can be very problematic because it is a very, very detailed file. But this program is specifically designed to handle that. So the one I'm opening up right now is actually our headquarters building up in New Hampshire. So we flew our quadcopter around the building. So figure no more than about 6 minutes took place. Just quick lap around the building, upload the photos, and then I have a 3D model. Now, again, this here is very detailed. It understood scale because before I actually uploaded the photos, I got a dimension in the real world of how wide these bays are, how tall the windows were. So when I uploaded the photos, I had some references that I can give it, so it could actually create the appropriate scale for everything. Now the tone that looks a little bit different here, that's because, again, I did this somewhat rushed. So I had more photos in the middle than I did anywhere else. So those best practices that I gave you, I don't always follow them for myself. It really just depends. For real projects, totally. But this was more of just a quickie as an example. So that's why it looks a little bit flaky here and there, is because it was very fast. I didn't get the requisite overlap that I said I should have got. But this now is solid geometry. I can get dimensions off this. This program allows me the ability to analyze it. So if I want to analyze it, I can do a couple of things. I can look at differences. So again, let's say we have an existing building that we took a lot of photos of. We've made a 3D model from that, or we've got laser scans. I can actually compare and contrast one against the other to actually see what parts are different. Where is it changing? Where's the variance? So I can analyze that kind of difference. Is something sagging or missing? If you're using this to make 3D prints, and I'll go into a little bit more detail why that might be of interest for historic preservation. But if I want to make a 3D print of this, this software allows me to help clean things up and make sure it's possible to do so. And in certain areas, you might always have something that looks bad. You know, maybe you had an area that was very reflective. Maybe something didn't work out right. One of the other really nice features of this software is the ability to go in and actually clean things up. So let's say this area here looked bad. I can select it and I can delete that. Now, in this case, I just have a big opening. But I can actually grab the edges of that and then go in and actually fix this. So maybe I want to refine that. In this case, what I'd like to do is fill it, though. So I'll say fill. Tell it I want it to fill that area smooth. Excuse me. Now, what it's not going to be able to do is assign the right colors there. Because it was getting the color from the photographs. But what this will actually do is clean up the actual geometry. It'll smooth this out. It'll fill in holes. It'll allow me to actually create the mesh the way that I need it to be. So if I find some areas are a little bit too busy, they're too far up and down, I can tell it to smooth that out. If I have areas that are broken, I can select them and delete them. In this case, I just deleted it and it smoothed it out with a patch to do what it is that I needed. Might not be the best example, but you can see how all I really had to do is select it and tell it to go, and that was it. Then if need be, I can massage it or modify it after the fact. And again, this is a completely free program. So from here, I can view my content. I can clean my content up. I can actually share my content or get dimensions by querying or running analysis on this. And if I need to actually see other things, I can always go back and open up different files. Now, most of the things that I've actually shown so far were more from an architectural bent. Now, I noticed a few other people actually checked different boxes for how you would actually look to utilize this. So one of them I said was a museum. I saw that got checked. Another one was more for sculptural. So this one here is actually a scan of a fossil, so basically a stone. So I mentioned before, the things don't have to actually be huge. So this is just the back of it, but if I look at it from the other side, I can actually see all the information inside of that. And I can query this and get ideas of the dimensions, how tall things are, what's the X, Y, and Z value difference between different areas. If I'm looking at something more along the lines of a statue, so this can actually load a statue. And this one here is one of the examples that Autodesk has. But you can see the detail that's still inherent in this. And this is all digital. So you can actually see how tight and how detailed the textures are, the surface of the mesh. And these are different things that we can actually put together, we can utilize, we can scan, we can query, we can document and archive. So that way we always have a record of where things were and how things actually looked at a specific point in time. So we looked at a couple of different programs here. Each one was using the different reality capture results slightly different way. Most of these are meant for reviewing or modifying or actually building from. And that's where the majority of use cases come from. Some of these, like Memento or Recap here, for a lot of people that are designing or in construction, it's sort of a middle ground. I'm using this to go from point A to point B. For others that are more in there for reviewing and archiving, they're not actually building from, this is the main tool that they'll need to use to get that kind of review or just that kind of information that they need. So pop back in. So let me go back to the documents here. John, you still there? Okay, that's not the right one. Okay, well, I can finish this. Okay. Okay, always good to have a backup. So one of the things that I wanted to show you here were a couple of different things that you could actually do with this. So what we're looking at here isn't just a sword. What we're actually looking at is a museum piece. Now, what they did was they wanted to have something that people could actually physically interact with. So they're not going to let people sit there and play with the actual sword. You know, that actually is a historic relic. But they wanted something that people could get an idea of and understand the heft and the detail and actually see the beauty of it. So what they did was they actually made a 3D model of the actual sword and the hilt. They used 3D printing techniques to actually print out the hilt. They built the blade normally. And now they actually have something that you can actually grab and hold and understand in terms of, you know, the actual relic. Other items you have here are from different museums. So the one on the left is from the Museum of the MoMA in New York City. The other one, I believe, is from the British Museum. And what these are 3D scans of actual artifacts that are in the museum. Now, on the left, you see the photo of one. And just below that, you see something that looks like the same thing, but it's in blue. What that is a 3D print model that you can utilize for that. And same idea on the one on the right. The left is the actual physical object. On the right is the geometry that they made from a scan of it. Now, what they're actually looking to do is, number one, have something that people can use in terms of outreach, but they're also using this as a form of having people understand and be able to get access to the real elements. Now, in some cases, you might say, well, they're going to lose all the revenue that they might get from the store. Well, 3D printing is not exactly the cheapest still, so in some cases it's actually cheaper to get it from the museum store. But if you're looking at it from a standpoint of outreach, so let's say you're holding an event trying to drum up money for some rehabilitation on a building. The ability to give somebody or to buy a model of that element and have it as a takeaway makes it a little bit more personal, gives people a different way of looking at history and at elements. Now, the other one is archaeology. So this is more using UAVs or drones. So in a lot of cases, and we're starting to see a lot more news come out of this, it's hard to move around in areas that are like rainforest. You're going to miss a lot of data that might be just next to you because it's hard to get a good view of it. And in some cases like this, it might take a long time to really document an area or to figure out where best to spend your time and document that area. So this is actually from Peru, where they reconstructed a physical model with just 241 photos from a UAV. So they flew a pattern, took the photos, and uploaded those. And the photos that you can get from there don't have to be red, green, blue. They can also be done as, excuse me, they can also be done as infrared, or so that way they're actually looking for different wavelengths of light, or they're looking for temperature. So they found things in different rainforests by looking at different wavelengths of light that we wouldn't have seen otherwise, or would have spent way too much time looking for. Again, it just depends on what we're actually looking to work with and how we want to get that information. Now, another one here. A lot of the best practices that I mentioned before was trying to maintain consistency. You don't want to have, you don't want to change your settings in between it. You don't want to look at it from different time frames. You don't want to bounce around too much. You want to have everything really nice and clean and be in the right order. That doesn't mean that it won't work if you don't, though. So what we're actually looking at here is the Bamiyan Buddha. And this one was actually crowdsourced, meaning that all the photos here are coming off of like a Google search. So they've actually done examples of this with the presidential sculptures. So they can take photos online of like Mount Rushmore and build a 3D model from there. Now, situations like this where we're looking at old artifacts is in some cases much more relevant today than it has been recently. This one here, the monument is actually damaged, so it doesn't exist as it did in the past. But because we have a lot of photographs of what it once looked like before it was damaged, it might eventually be possible to fix it or to actually create a reconstruction of this. You might have seen in the news recently that a lot of artifacts overseas were destroyed or damaged. Those are things that are now lost to time. Some things that were priceless and there were no other versions of that. So using the reality capture is a method of archiving almost the real world. You now have this element that can be continually studied. So if you have people that are looking to do research or study objects, maybe they can't get to that element. But by sharing the files digitally, they can actually look at it and do studies from wherever they are. So this really is an important thing in terms of understanding how we can preserve and use that data either to A, to archive it, or to B, to fix it and make sure that it stays in a usable state. Now, in terms of where things are going with this. So in most laser scans that people tend to see are those sort of blocky elements that end up on top of a tripod. So what you're looking at one now is called a ZBD. So this essentially looks a little bit like a Ghostbuster wand. But what happens is as you walk through a space, it's constantly bouncing around and changing direction and getting a large amount of data. Now, in some cases, it might not be as dead-on accurate as the tripod-based, but the benefit is you're able to scan certain areas that maybe you would not have been able to do otherwise. So this is actually a point cloud model of the Leaning Tower of Pisa. So they were never able to actually get a good scan or a good existing conditions documentation of the stairwell because it's angling in all these different directions. It's very tight. So they never really had anything to work off of. This gave them an actual full-on laser scanned existing conditions model that they can now work on, whether it's from an understanding of, okay, well, how far is it leaning, where are things happening inside, what's the elevation, where do we need to work on preservation. So this is being used a lot overseas. Now, on the other standpoint, you have things like UAVs. Anytime you're, for the most part, seeing a UAV, whether it's fixed wing or if it's a quadcopter, those are all tend to be more photo-based. But they are actually looking at working on ways of making a laser scanner that is light enough and making a platform that has enough power to take off with this and enough battery length to actually make it useful. So not really there yet, but it should be there in the next couple of years. Now, other things. I mentioned sensor-based earlier on. For those who haven't heard of it, Google was working on something called Project Tango. Project Tango was essentially had two different bases. One was a phone and one was more of a tablet. But what it actually did was it used that form factor and some of the hardware that was attached to it to scan real spaces. So this allowed you to use your phone to document a three-dimensional space. And like anything, there's going to be multiple ways of actually looking at that 3D space. Whether it's from the standpoint of using it for video games, so that way it's easier to monetize, or using it for waypoint tracking for advertising for them if you're walking around and inside of a building, or for just general mapping of a space for anybody who can't afford a $20,000 scanner. So it's in no way, shape, or form as detailed as the others. But if you just need to get general ideas, it's hard to beat that. This may or may not be available this year. They haven't had too many pieces of information released recently. But the idea is, if you look at where most sci-fi is, so as an example here, if you saw the movie Prometheus, one of the things that they showed in there from a technology standpoint were these little scanning devices. So a little ball you throw in the air, and it would run through corridors autonomously scanning and then building a three-dimensional model that you can then view remotely and understand and track where things are. Now, this tends to be more in the realm of, or very much in the realm of sci-fi, but that doesn't mean that this kind of thing is not almost there already. So what I mean by that is this. So, share document. Now, this video is not recent, meaning it's not something that just came out last week. It's actually, I think, a couple of years old at this point. And what you're looking at is a autonomous drone. So no one's sitting out of control, no one's flying it manually. It's being told programmatically to go into a space and then work its way through and actually scan where it's going. So the one image on the right is where the drone is. The image on the upper right is what the drone sees. And then the map that you're seeing is actually a live feed of it building a 3D floor plan, essentially. So the idea of having those little pups from Prometheus going